Hello and welcome to another video. In this video we're going to be going over Bitwise XOR of all pairings. And in this one you have two arrays, nums1 and nums2, and you have an array nums3 which contains the Bitwise XOR of all pairings of integers between nums1 and nums2. Returns Bitwise XOR. So this example has more numbers, so let's go through this example. This is basically going to be easier. So essentially you're going to have all pairs of integers in here and in here. So for example, 1's going to get paired with 3, and it will also get paired with 4. So we can write that down. So 1 will get paired with 3, 1 will get paired with 4, 2 will get paired with 3, and 2 will get paired with 4. So your number of pairs is n times m. Then for every pair, you XOR the numbers in the pair, and then you also XOR all those results. So here, 1 XOR with 3 will be 2. Then we're going to XOR this with this result, which is 1 XOR with 4, which is 5. Then we're going to XOR here. This is 1. And this is 6. And so what does this look like? So 2 looks like, whoops, this. 5 looks like this. 1. You can have some zeros. And 6. Okay. So when you XOR a bunch of numbers, basically the bit that's going to happen is just going to be, is there an even or an odd number of ones? If there's an odd number of ones, it'll be 1. If there's an even, it'll be 0. So this is 0, 0, 0. So the main thing to notice in this problem that makes it kind of easy is all we really have to do is figure out, like we know that every number in the first array will appear in the result how many times, right? It'll appear the length of the second array. Because 2 will get paired with everything here. So like if we go back to the first example, this 2 from this first array appears, like if we just make two numbers, let's call n1 the length of nums1, and let's call n2 the length of nums2. So 2 will appear in this result n2 times, and then 1 will appear in this result n2 times, and 3 will appear n2 times. And now from the second array, 10 will appear n1 times, 2 will appear n1 times, 5 will appear n1 times, and 0 will appear n1 times. Now we can kind of break down each of these individually. So if 2 appears some number of times, like if we just focus on how much this number appears, if it appears an even number of times, right? Because we're not really doing anything with the pairs if you think about it. Like we're just XORing every single number in here. So the pairs actually don't really matter. All we need is the frequency of every number. Like we're not, like it doesn't really matter in XOR. It's kind of like addition. You can do it in any order. So I could do it in this order where I XOR all of these, or I could just say like, well, I could just like XOR 1 with 1, and then XOR with 2, and then XOR with 2, and then XOR with 3, 3, 4, 4. And this will give me the exact same thing as if I move these numbers around, just like addition. So as long as the frequencies and the numbers are the same, it doesn't matter. So we don't care about the pairs, we just care about how many times every number appears. So we know that every number nums1 appears nums2 times. And there's only two cases we care about, and that's just, is nums2 even or odd? So if nums2 is even, that means each of these numbers appears an even number of times. And if a number is XORed with itself an even number of times. So a number XORed with itself is 0. And so an even number of this is just basically this happening a bunch of times, right? Some y number. So if nums2 is even, then every number in here will just become a 0. And if nums2 is odd, then what's going to happen here? Like, let's say x appears like 15 times. Well, the first 14 are just going to cancel out to 0. And then the last one is just going to be the number itself. So a number XORed with itself 15 or some odd number of times will just give you that number. Because the first even count will give you 0, then the next one will give you that. So essentially, all we really have to do is just check, like, okay, well, is nums2 even? It is. So all of these are going to be 0. Now, for these, is nums1 even? No, it's odd. So all of these will appear once. So all we really need for the result is just this, which should give us 13. And so we can take a look. So 10 is this, 2, 5 and 0 is 0, so 1 1 0 1. So this is, maybe I did something wrong actually. Let's see. Yeah, so this is wrong. This is not the right number. This should actually be this. Okay, so 10 should be this, 2 is fine, 5 is fine. Okay, so now let's see. So 1 0 1 1. There we go. And this is 13. And then at example 2, because for all of these, this array is even, that means these will just be 0. And for all of these, this array is even, so these will be 0. So then you just have 0. So that's literally all we have to do, is just get a length of each. If it's even, then the other numbers will never appear. If it's odd, the other numbers will appear once, so you just XOR all those. And so that's what we're going to code. So we can just get like n1, n2. N1. Yeah, and the important thing to realize, like, the pairs don't matter at all, so I don't need to actually make the pairs. And XOR of a bunch of numbers, the order doesn't matter, it's just the same as doing addition. So, result. Okay, so if nums2 is odd, then we're going to take every number, or if nums1 is odd, then we're going to take every number in nums2 and add to the result. So. And we're just going to XOR the result with that number. And same exact thing for the other one. So if nums2 is odd, then we're going to go through nums1 and do the same. And if they're both even, then result will just stay 0. And that's all we need. So let's submit that. Okay. Yeah. So time is pretty simple here. So essentially, worst case, we go through both arrays. So let's be like n plus m or something. And space is 1. Yeah, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.